Hello all, welcome to Rupa's online tutorials. In my previous video, we had discussed some of the important concepts of database, and also I told you that those are the frequently repeated questions in your second PU board exams. Here we look at some more concepts. Data abstraction. I think you're all familiar with this word, data abstraction. We've already learned it in C++ when you would have learned in your first PU, or even in here the second PU in object-oriented concepts. The same definition holds good here even for the databases. It is a process of hiding unwanted or irrelevant details from the end user. Irrelevant means which is not important. Okay, so we have learned data abstraction is the act of representing only the essential features of an object and hiding the background details. So the same thing holds good here. What is the use of data abstraction? It helps to provide a different view and helps in achieving data independence. I'll explain to you what is data independence. And it's also used to enhance the security of the data. Enhance means to make it more secure, to make it more, safe. Okay, the data has to be safe from unwanted people. It should not be accessed by everyone. So for this, data abstraction is absolutely necessary. So there are different levels of this abstraction. So it's also known as the different levels of DBMS. So there are basically three levels. First one is your physical schema. Okay. Then it comes to the conceptual schema. The third one is known as the external schema or the view level. So what is the physical schema? Now what is schema? Schema is nothing but the structure. How we are going to define the database, that is known as schema. So coming to these three levels, the physical level or the internal level, it is the lowest level of data abstraction, and it tells how data is stored and organized on the storage medium. Okay, so how data is stored and organized on the storage medium. Storage medium is maybe your disk, okay, your hard disk, and how it is stored, like how much memory is allocated, or how much space is allocated, how much space is allocated, what are the indexes provided, etc., is discussed in the is the matter of concern in the physical level or the internal level. The next level is known as the conceptual level or the logical level. So here it describes what data is stored in the database. Okay, so what data means the type of data you're going to store, numeric data, or the tables that you're going to create, what are the relationship among the tables, etc. For example, you're going to have an employee database, then how many tables you're going to have? You're going to have let us say you're going to have one table for salary, one table for employee personal details, one table for his loan details, etc. So it can be any number of tables. So here is where the actual database design is happening. Okay, and the relationships among the data. So relationship is when you are using an RDBMS, you need to know that how each table is connected with one another. The external level or the view level. So this is the highest level of abstraction. So here it deals with the user's view of the database. It is also known as the view level. So here the user is only knowing that okay, he has to enter some data and he is going to get some output. So he is actually not concerned with how the database was designed. He is not concerned with how it is stored in internally, how it is stored. No, this is only the user's view of the data. Okay, the user is just going to log into that particular database, and he's just going to see what he wants to enter. For example, if you have a student database, okay, and the person is entering fees for him, okay, him or her, so he is only concerned with the student name and what is the balance fee that he has to pay, which class, which course he has taken, and all those things. Now he is not concerned about the marks or how he has performed academically and all. So here this is describes the part of the database for a group of users. So one set of users are going to actually take a part of the database and view it. For example, your class teacher, he or she may want to see your marks and your performance over the period of time. So they are not now worried about whether, I mean, they're not looking at like what is your personal details, or they're not looking at whether your fees is being paid, or all these things will be taken care with the admin. So hope you understand what I'm trying to tell. So these are all levels of abstraction. Okay. There is another important term that we describe here, that is known as data independence. See, data independence, this definition, we should be aware, this definition, data independence, is the ability of a database to modify a schema. Schema, I told you, it's the structure of the database, okay, at one level without affecting the schema at the next higher level. That means what? If I'm going to change something in the conceptual level, just now I told you the logical level, okay, I'm making some alteration in the table, okay, then the external level is the user's view. Now here the user should not get affected by whatever changes I make here, like it should not affect this level, okay, it should be done in such a way that any changes made here is not affected here, okay. So that is called as data independence. Okay, so data independence can be done on both the logical schema as well as the physical schema. So logical schema here is logical data independence, and physical schema is the physical data independence. In logical schema, you have how they achieve this data independence is through something known as normalization on relational model. Okay, our relational model is in the form of tables, rows and columns, and through entity relationship or ER diagrams. And then we have file organization. This is physical medium. This is how the data is allocated in your memory. So that is done through the different data models and the database architecture. So here this is done for physical schema, and this is done through logical schema. So coming to this physical data independence, okay, the file organization. See, file organization is mainly used because you want to read it is faster to read the records, to retrieve the records and access the records quickly. Isn't it? Like even if in your table you keep things wherever you want, it will be difficult for you to get those things back. Otherwise, if you are neatly organized, okay, keep your things in a very an organized way, it's easier to get it back. So simple like that. Even your files, when they are organized properly the records are organized in a proper way inside your computer, it is easy to retrieve. Retrieve means to get back the records, access the records quickly. Okay. Here we can quickly perform the operations such as insert, update, delete on the records present in the database. The storage cost is minimal because the information should be stored efficiently. So there are three types of file organizations in DBMS and RDMS. So what are they? Excuse me. It is sequential file organization.